would say that either they really, really knew what they were doing or they really, really didn't know what they were doing. That's what I would say. You either got it down. I had very few in between there. It was like got it down or didn't have it. Several really, really good grades and some really bad grades.
Okay, so we're going over that next Friday. Today we're going to start talking about, what was it, 3.2? Is that what this section is? Yeah. Yesterday we introduced the quadratic formula. Do y'all remember what the quadratic formula is? Do you think you could write it like without looking? Do you think you could write it like right now? I think that's the first thing we should probably try to do, is like see if you can remember what it is.
And when I was grading papers last night, I noticed that, and I'm just going to tell you all this because it's a common mistake. It's negative b plus or minus square root of b squared minus 4ac. The fraction bar goes over all of that, not just the radical part. Some of y'all were doing it negative b and then plus or minus the square root of b squared minus 4ac, and just the plus or minus b squared over 4ac would be put over the 2a. So you have to make sure that the whole thing, 2a is the denominator of everything.
All right, I got to set up my Droid camera quick. There it goes. Oh man. When I was a tutor at Eastview, someone decided to do some graffiti on the hallway on the stairs.
Oh gosh.
It was a Pythagorean theorem, or not the Pythagorean. It was a quadratic formula, but like they like missed the negative sign on the B. They got it wrong. It's like, at least if you're gonna tag something, get it right so you can see it. You're gonna make people memorize that stuff wrong.
Did you go back with your marker and correct it?
Of course I didn't graffiti school property. Probably not. Not while I'm recording. Yeah. Is this? Well, let's go to my screen and help out. Are y'all ready? Okay. I already flashed it, I guess, huh? Do I still get it right? Okay. X equals negative b plus or minus the square root of b squared minus 4ac all over 2.
Over 2a.
Okay. So this is the quadratic formula. So if nothing else, like this thing will get the thing factored, right? That's the kind of the basis of this thing. We can find, we can find the zeros is what it is, I guess, not the factor.
Well, you could find the factors, because if you find the zeros, you can go backwards.
Yeah, you can go backwards.
Yeah.
And so we're not technically getting to that, but like if x is equal to k, right? The factor would be something that looks like x minus k. So we're not there yet, but that's something that they will throw out at you in the future. Like this is your zero, this is your factor. And it's true for quadratic. We're going to get to larger stuff. It's not quadratic, that's larger than, quadratic and factor in it. My brain crossed wires. So if your zero is some number k, the factor looks like x minus that thing, is one way that they say it. So there is a relation between zero and factor, and it's not super complicated, right? It's like minus the thing equals. Okay. So this is a tried and true way that will like always get this thing simplified. You can always solve it, but it is like really, it's a lot of stuff to do, right? It's a lot of work. You don't always want to do this. If you can factor it, if you can find another way to get at it, that's what we would prefer. So I definitely need to zoom in. Focus this thing. That's probably better. We're starting on 149. Yeah, okay. 9.3 is why it's so high. I forgot there's those two problems from 9.3, and then we jump over to 3.2. The 149 and 151 are the first two problems we're looking at. And so in this, it says in the following exercises, identify the most appropriate method, factoring, square root, or quadratic formula to use to solve each quadratic equation. Do not solve. So solve these. So we're not doing 150. So what I want you to take a look at those 6 problems. Okay. How would you solve 149A?
Quadratic formula?
So before you do quadratic formula, you want to see what? If it factors? Can we factor this thing? So what numbers are we looking for? Or how would you try to factor this thing, I guess is the question. Would you use square root, or would you use like AC factoring, I guess is the other thing, right? Or factor by grouping, one of those things. What method would you use?
That's just AC method since equals 0.
Yeah, so AC method. So using AC method, can I do this without giving away the magic numbers? I'm looking for something that multiplies to what, -24 and adds to -5, right? So what magic numbers are you getting for that thing? 1 and 24, 2 and 12, 3 and 8, 4 and 6.
3 and 8.
3 and 8.
I'm sorry,
And
-8. Oh,
yeah, the 8 would be negative, so that when we multiply, this would be negative, and what? This would be negative when we add.
Right.
Yep. So we have it here. X squared minus 5x minus 24 equals here. So we found the magic numbers. How do you want to factor this thing? I'm going to ask you all this. Do you want to break up that middle term? You can go for it.
Sure.
Okay, we can do that. So factor here and here, here and here. Between these, I think I can take out an x, and it leaves me what, x plus 3. What can I take out here?
8.
Yeah, should be
Yeah, -8.
-8 with it. Yeah, so you can take out the negative with the 8. If you didn't take out the negative, your signs wouldn't match up, right?
Right.
Yeah.
That
That goes back to that thing. If it leads to the negative, take out a negative. So x plus 3 and x minus 8 are hopefully the two things you see there.
Equals 8. X equals -3.
Yeah, I hear some grumbling.
Oh crap! Yeah, that's me. Sorry.
No, you got it. It sounded right. X
I
plus
appreciate
3
it.
equals 0. X is equal to a minus 3 when we subtract the 3 over. X is equal to positive 8 when we add the 8 over.
Right.
This is my solution. This is my solution. If I'm not sure of my answer, what should I probably do?
You can always plug it in.
I
Or
can always go plug it back into this thing. I can go take this thing, plug in a minus 3, right?
right.
I can go, even if you have a calculator, it makes it really simple, right? Probably.
Uh-huh.
It's easy to check your solution, especially on a test, and do it. Do it. Just do it, right?
Put that on a t-shirt.
Yeah.
-3 parentheses.
How am I gonna do? What's my process on B?
Since it's a squared, you write out y plus 5 parentheses and then write it out again. I think it's y minus 5 this time. Or they're both the same, where it's y plus 5 and y plus 5.
It should be
Equals
both the
12.
same if you're gonna write it out. Yeah, it's the same thing.
Yeah. Okay, just making sure. Right, because there would be a plus or negative sign in front of it. My bad.
So if I start with this, I think what is the process that I'm gonna do to solve this thing? Like what?
Figure it
How's?
out.
I'm sorry, I think I spoke over you.
It's okay, I said factor it out.
I wouldn't factor this thing. It's
Yeah.
really kind of set up for something. We see this thing, and the important
Oh
thing.
wait, square root. Wait.
Yeah, square root.
Yeah.
This thing
the
is
exponent.
something squared. Like if you see something being squared, whether it's like a y square or maybe we could have two things in there, right?
Right.
We just see like a single square term. That should be like a whole, hopefully a giveaway that take a square root, you can get rid of the square. If I take a square root, I've said a million times already, probably say a million more, you got to take a plus or minus. We're expecting two solutions. This is the thing that's giving us two solutions, right? Plus or minus. 1 plus 5 is that thing without a square.
Well, it's not a perfect square, so I got 6, 2, 3, 2, 2 square root of 3.
I think I heard 2 square root of 3.
Yep, that was me. And then we would subtract the 5.
Yeah, I can think of that as what, 4 and 3? And then you said subtract 5. And then leave with the minus 2 I'm gonna put over there. Plus or minus 2 root 3. So I know a few people were like moving this plus or minus in front or something like that. Plus
Before I
or
used to
minus
put
it should be on the radical term, right?
right.
Oh boy.
Good.
One more. 14m squared plus 3m equals 11. So looking at this, it doesn't look very pretty.
Boy.
But what's the first thing I should probably do?
Subtract the 11 to make the equation equal 0.
Yeah, put it in standard form. And so the first thing we want to do is see if there's any way in our little pocketbook of factoring that we got a rule for factoring this thing. So 14 by 11 is what? 154. Do you know the little 11 shortcuts when you multiply by 11? You do 14 plus 14. And you just move the 14 over. So multiplying by 11 trick. You just put the number over like one decimal place, basically. It's like a 10 and a 1 in there, basically. Okay, anyway. 154. Oh, God. Let me see. 154 divided by x. Let's see. So I'm definitely pulling out my calculator. 1 and 154. I want to do, what, 2 and 77. So I want to look at all these factors. And it is a negative 154 that's multiplying 2, and it has to add to 3. Let's see. Oh, well. It's probably not too hard. 11, 12, and give me that. Okay. So if I'm looking at all these factors and I have to add to 3, can I factor this thing is what I'm asking.
Yes.
Yeah, you can get it by making what? 11 and 14 have a difference of 3. And if we want to make it a positive 3, I'm going to have to put the negative on 11. So this one I think will actually factor. I was hoping they would give us one that wouldn't. So 14m squared minus 11m plus 14m minus 11 is 0. I haven't done the box method in a minute. I think I kind of want to do that. So if I'm looking between 14 and 11, I don't think I could take out anything. Between m squared and m, I could take out an m. 14 and 11, I got nothing. I think I can just take out a plus 1 here. Between 14 and 14, I can take out 14. Between m and m squared, I can take out m. There's a negative here, and I could take out a 11. Check out. I didn't double check it. Okay. Looks like it checks. And this is equal to, don't forget you're equal to 0. Okay, so we factor this thing. And then hope you're finishing this up. Hopefully I'm not giving away too much here. We've done a few of these by now, I think. Set each of those factors equal to 0 and solve, right? So positive m is, and we subtract it over. Questions? Are we getting these? So these, I think we're not even using quadratic formula yet, right? 6a squared plus 14 equals 20. How might you want to do this one? And there are a few ways you could do it. There's one way I would probably do it, if I'm being honest. What does it look like it's set up for? What is in your equation? What sort of term is that?
Square root?
Yeah, you could do square root property. So there's two sort of ways I'm thinking you could do about this. You could try to do the AC method, right, and try to subtract it over, and you'll have like a difference of squares there, I think is what will end up happening. But the thing that I would do is a square root. I noticed there's a square term. Everything else is nothing but constants. What I want to do is I want to get my square term by itself. Just solve for my square. So I'm solving for this. So what is the process?
Subtract 14.
Yeah, subtract 14 and then what? Divide by 6. 6 squared is equal to, this is going to give me 6. And now I'm dividing by 6. So a squared is equal to
1.
1. And if a squared is 1, can I do it without saying it?
A is 1.
Oh, be careful. If you take, I don't want to finish that sentence. What am
Plus
I
or
missing?
minus 1.
Plus or minus. Yeah. Don't make me say it again. We took a square root. So this is a square root property. If you take a square root, you have to do plus or minus 1. I think if you do it the other way, if you subtract 20, you're going to get something like 6a squared minus 6. So you can do these things multiple ways. There are multiple ways to get at these things. Pull out a 6, you can be left with the difference of squares. This is a plus 1 minus 1. It will give you the same solutions. So there are multiple ways to get at some of these things. With that one, it's kind of set up and suggesting you do the square though. B, there is really only one way I would want to do this. What is this set up for? It's like right there. What should I do?
Square root.
Square root. Square root property, I have to do plus or minus. So this is probably not the prettiest thing, but there it is. We can clean this up a little bit. This looks like x minus 1/4 now. This is equal to plus or minus over 16. The way that I would do it is I would separate this root to the numerator and denominator. So I think we've done some examples like that. If we have a square root of a fraction, we can think about it as like this thing over this thing. Part of the reason why I'm doing that is because I can clean up that denominator, right? Square root of 16 is just 4. And the last thing, what? I'm going to, right there,
Add 1/4.
add 1/4 over. So x equals what, 1/4. I'm going to have like something plus or minus root 5 over 4. And if you wanted to, you could in there, if you wanted to combine it as one sort of fraction, that's also okay. Either way is equally acceptable. There's really no preference there. Okay, so y squared minus 2y equals 8. So the first thing I want to do is do what? See if this thing's factorable. So I got to do what to this thing?
AC method? Or set the equation equal to 0 first.
Set it equal to 0. Then I'm going to look at this thing, try to do the AC method. So I'm looking at a minus 8, and it has to add to minus 2. So 1 and 8, 2 and 4 are my two options here. Are we going to get them to add to minus 2?
-4.
-4 and 2. Okay. How do y'all want to factor this thing? Do you want to break it up or jump? That's my question.
I usually jump with the single.
Right? To those factors. So this is going to be y. What?
+2 and -4.
+2 and -4. So I can jump right to my factors of this. If the a is 1, right? Okay. And I don't want to spend a whole lot of time with jumping through these. Y is what? -2 or y is 4. Okay, 25. It says to solve this thing. So I guess the obvious thing is should I go x equals 5, 3x plus 14 equals 5? Is that a good strategy? Hopefully, I hope you're all saying no, right? What do I have to do to this thing? What is the strategy? Sorry, what was that?
Divide.
Divide, is that what you said?
Yeah.
I'll just say distribute the x.
Distribute the x, right? We want to distribute this x. So if I distribute that x, it becomes what? 3x squared plus 14x equals 5. So what am I trying to do? Subtract the 5. 3x squared, 14x minus 5. So this is equal to 0. And we want to see if this thing is factorable. I go method, hopefully is what you're thinking. I go 3 times -5 is a -15, and we want them to add to +14. So can I find two numbers that do this?
You can, -1 and 15.
-1 and 15 are the two factors. How do I want to do this? Box method, maybe? Once more.
Sure.
3x squared, I have a -1x, I have a plus 15x, and I have a -5 is what it looks like. So if I'm looking here and here, I can pull out an x. Looking here and here, I can pull out a +5. This leads with the positive, pull out the positive. Between 15 and 5, I can pull out 5. This is what? X squared and x squared, I can pull out an x. And 3 and 15, I can pull out a 3. This is leading with the negative, so I'm going to pull out a negative. 1 and 5, I can only pull out 1.
Set them equal to 0.
Okay, so this is 3x minus 1. And what? X plus 5. And I set them equal to 0. So now I'm using what? 0 positive rule. We've done this a few times. So either this first thing is equal to 0 or the second thing is equal to 0. Now I have to solve each of these equations. I have to add the 1 over, so that gives me 6. is a positive 1. I got to divide by 3, so that gives me x is
Equals 1/3.
1/3. So I would be like really careful, like on this step, if I'm being honest. Like slow your roll a little bit when you get to this step. Like so many times y'all will get to this last little step and then you will divide these things in the wrong order. You're gonna give me 3/1 or some crud like that. And it's so disheartening, man. It's like you're right there. X equals a -5. Even on these, like subtracting them over, so make sure you subtract them over, right? The sign's gonna change. And it's not like y'all don't know how to solve these. Y'all just get in a hurry or something. I don't know. Get test brain, I guess. That's the thing too, huh?
Yeah.
Okay. Are there any questions about these?
Not really.
All right. 25, what was it?
Graphs. Oh shit, I'm not on mute.
25, 45, 47. Okay, so on these, find the coordinates of the intercepts. They try to make you solve these things. We're not going to solve anything graphically. I don't know how to tell you this, break it to your heart. But I don't want to solve anything graphically in this class. Like that is a very bad sort of thing to do. I've got my little example here. I'm going to go share it for a minute. But this is my infinite candy bar example. So graphs are really deceptive, right? If you look at them just the wrong way slightly, you're going to get the wrong answer. So this is my infinite candy bars. This is basically a way you can deceive yourself with graphs. So if you want, you can count the slope of the first line. And this is the infinite candy bar GIF. So it's pretty common. You can find it out there. But if you count the slopes, they are different slopes, starting versus when they're ending. And there's this little deceptive sort of thing that's happening. They're basically squeezing out an extra piece of candy from this thing by changing the slope up. So they're pulling out a little piece of candy from each of these things. And overall, you don't notice it. It's like one of those near misses sort of things that happens. So that's my reason why we're not doing things graphically. So if you want my source for this is infinite candy bars. So we want to solve this thing, but the graph gives us a pretty good idea of what's happening, right? One of our zeros should be between 0 and 1. Another one should be between -2 and -3. So it definitely tells us like where our solutions should be about, right? It's not completely the worst thing. But if I want to know where my intercepts for this thing are, and this is my function, how do I find my x-intercepts?
Set it equal to 0.
I set my y equal to 0. So this thing is equal to 0. I want to know where it crosses the 0. So we can do it with one line. Another way they do things sometimes is they will say like this is y equals 0. This is y equals this thing. So where is this thing equal to this thing, right? We can think about them as the y equals lines as horizontal lines, right? We talked a little bit about that before, with horizontal lines. But how do I want to try to do this thing? I want to see if this thing factors.
AC method.
AC method. So I'm looking at what, -30, and it's going to add to 13. I think those are all my factors. 1 and 32 and 15, 3 and 10, 5 and 6. So one of them has to be negative, one of them has to be positive for it to be negative. So I'm looking at a difference of 13. Can we get that here?
Yes.
Okay, so what are my numbers I'm looking at to get a difference of 13?
-2 and +15.
These two right here. 6x squared minus 2x plus 15x minus 5 is equal to 0. So I'm doing the AC method here. So I think I'm going to do these by grouping. I think I did 2 boxes. Between 6 and 2, I believe I can pull out a 2. Between those x squareds and x, I can pull out an x. And that's going to leave me with what, 3x minus 1? Here, I can pull out what?
5.
I can pull out 5, and I hope that leaves me with a 3x minus 1. And squeezing my equals 0 on the end of my paper there. Okay. So you can always double check, right? 5 times 3x is giving me 15. 5 and negative 1 gives me minus 5. Okay. 3x minus 1 and 2x plus 5 are my 2 factors that I'm getting out of this. And now we have 2 factors equal to 0. We have done this a few times, but I can use what? 0 product rule to get my 2 factors. So either 3x minus 1 is equal to 0 or 2x plus 5 is equal to 0. I think for this one, I'm getting 1/3. For this one, I'm getting 2x is a minus 5. X is a minus 5/2. Okay, might be beneficial to say like that's minus 2.5, right? Minus 5/2. One-third, if you put it in your calculator, you might realize it's 0.3 repeating, right? So that might help. Although we know 1/3 is between what? 0 and 1, so that one's not too hard to figure out. We get 1 0 that's between 0 and 1. We get 1 0 that is between minus 2 and 3. And they ask for the intercepts. Is that what they asked for? Find the coordinates of the intercepts. So we have our x values. What should we really do? Put them in intercept form. So what does that look like?
One-third or 0.3 repeating, comma 0,
Uh-huh.
and negative 5/2, comma 0.
Yep. And so they're trying to like nail home like all this vocabulary sort of stuff in this chapter, I think. Like if we set our function equal to 0 and solve for it, that's like solving for the zeros of the function. That's like solving for the x-intercepts. These are all saying the same thing. We're solving for the x values of the x-intercept, right? If they want the intercept, it's going to be like this sort of thing. It's going to be the point. Okay. 45, 47 is this one right here. Y equals 9x squared plus 30x plus 25.
I think that one's number 48. 47's kind of cut off.
Is 47 the one above it? Is that what it is?
Yeah,
I thought this
think
one
so.
was. I thought this one was 47, but I could be wrong. I can look it up right quick, I guess. This is Roxwald 3.2. Is that what we're in?
Yes.
And that is number 47. Let's go to the exercises. All right, let's take a look. Oh, there we go. It is very similar. So I think we'll probably go ahead and do both of them. Okay, so this one looks like y equals a minus 4x squared plus 12x minus 9. And it looks like it's hitting the axis square between 1 and 2.
Yes.
All right. So we want to factor this thing. How would you factor this thing? Or what's your first step to finding the intercept? So we have our equation. We're going to set our equation equal to. Not too fast now. Okay. So set your equation equal to 0 to solve your x-intercept. So we want to do this thing. We want to factor it. This is a really dirty trick to do. I like tempted to see if y'all see it. Maybe, maybe not. I wouldn't want that thing leading, if I'm being honest. And I think it was a rule before, right? If we have it, if it leads with a negative, take out a negative. So what happens if I take out a negative here?
All the signs flip.
Yeah, all the signs are going to flip. Do I really need to be concerned with that negative is what I want to look at next. I know I took it out, but really I could just do it. I could just divide everything by it, right?
Uh-huh.
Yep. So I could do this. This is something you can absolutely do. So if there's like a constant coefficient, if there's a negative, you can multiply both sides by a -1 is another way to look at it. But I can basically kind of flip my sign. And now I'm solving this equation, and this equation looks a little bit easier to solve. It is in a special form. If you notice, it's in a special form. If not, you can always do what? AC method. So 36 and adds to -12. I'll give you a hint. It's going to be the same number. And if it's -12, they're both negative. I'm going to give y'all like 1 minute. How does this thing factor? Are y'all getting this?
Yeah, it's still working there.
All right, so what is it? Just jump to the factors.
4x squared minus 6.
Oh,
Factor, my bad.
yeah, just jump to the factors. It is in a special form, right?
2x minus 6.
2x minus what number?
What are we doing? So that would be 3. No. I'm putting 3 down.
That's it. And this is a perfect square.
Yeah.
We just square root of that, square root of that. And then we have to check the middle number, right? But the middle number we'll check. It's 2 times 2x times -3. This is factor by grouping or box method, right? To get there. We did a few of those. I was just trying to skip a step. Okay, so 2x minus 3 equals 0, or guess what else? Or 2x minus 3 is 0. So either 2x is equal to 3 and x is a 3/2. Or guess what else? X could also be 3/2. Okay. So if I sound like a woodpecker with a headache or something, I don't know. I guess it's a mockingbird with a headache, right? With that one. What is my x-intercept here?
X equals
Three.
positive. Go ahead, Hunter.
All right, 3 halves and 0.
3 halves and zeros, my x-intercept. So it is, you're getting how many solutions? That's my favorite question to ask. It's a weird question, right? We're getting x equals 3 halves, so we're getting the solution, but we're getting it twice, right? So we're getting one solution with a multiplicity of 2. So we are still getting the 2 solutions we expect from this thing. Does this make sense with what it looked like pictorially, hopefully? We were expecting 2 solutions, we only got 1. And it was a number that looked like this. So we get 1 x-intercept. Is that what is happening graphically? Do you see how that matches up with the graph, I guess is my question.
Yes.
It only hits the graph once. So if we get 2 solutions, it's hitting, or 2 real solutions, it's hitting the graph twice. If we get 1 real solution, it has to be repeated. It's one of those weird things. It's hitting it and it's turning it back around, right? It's like it goes into the party, it sees someone it doesn't like, and it just turns right back around, right? Okay, so what about 48? And it should be very similar. So if we look at this thing, I'm hoping I don't have to spend a lot of time factoring this thing. It should be a perfect square, hopefully. So what does my perfect square look like on this one? Do y'all know the shortcut on that thing? What if you square root this, what do you get?
3x.
3x. This side is positive, so this side is positive. If we square root this, what do we get?
5.
5. So it should be 3x plus 5. And if we check that middle term, 5 times 3x is going to give me 15, plus 15 would give me 30. And so now we can create things. If you want to just write this out once, I guess we could just do that. But 3x plus 5 is 0, or 3x plus 5 is 0. Means 3x is a minus 5, or x is a minus 5/3. So what is my intercept?
Yeah, 5, 3, 0.
Yep. And does that match with what it looks like graphically? So minus 5/3 is minus 1 2/3. Is that what it is? Minus 1.666.
Yep.
And does that look like what it is on the graph? That looks about where it is. Okay, so we got 3 more to solve graphically on here. I know we're like running hidden time. So the thing is on this section, I plan to finish this on Monday if I'm being honest.
Okay.
I'm trying to spend some extra time on this and get at this factoring stuff and get at how to solve these zeros. Because there are multiple ways and we haven't even done any that are like quadratic yet, right?
I don't think so.
Yeah. I think it was no quadratics. What's up with that? So we want to solve, they say solve these things graphically. We're not solving them graphically. We might look at a graph to check our solution, right? But I want to solve these things symbolically. So x squared plus 2x equals 0. Oh, this one should be quick, hopefully. You know it. If not, it might make you spend some time on it. You could try AC method, but this is something even simpler on this one.
Hey, turn it down, will you? Jesus.
X squared plus 2x equals 0. So how would you factor this thing? Oh, you had something like this on your last test, didn't you?
Yeah, we did. I think, but I got it wrong. So
Yeah. Okay, so like the first thing when you're factoring, you always look for a GCF. Look for a
Right.
GCF. What's my GCF between these things?
X.
I can pull out a.
I believe X plus 2.
And this is still equal to 0. So right here, I hope you got this thing down. We've done enough of these problems at this point. But what are my two options? So x is equal to, or x is equal to, or x plus 2 is equal to. So I have two things I have to account for here. So maybe I shouldn't jump to that. You do have to account for this one, right? X is equal to 0, or x plus 2 is equal to 0. X equals 0 is already solved. This one I have to subtract the 2 over. And so again, this is my x equals, if I want the coordinates of the intercepts, what would I do? This, I can do this.
0, 0.
Yeah, that was
And
0,
minus
0,
2, 0.
and minus 2, 0. It should go through the origin. Okay, so I want to just do, where are we at? Quick Desmos. So x times, let's do x squared plus 2x. X. Is that going through where we said 0, 0 and minus 2, 0? And I think on Desmos you can even check it, right? It will usually give you your intercepts. And if it doesn't, you can always go y equals 0, right? I think. And you can look at where these intersect. I think it usually shows you points of intersection, even if it doesn't. I think. Let's try it. Is it? See, it gives you points of intersection even. They don't even have to be zeros. Look how nice Desmos is. The next one looks like x squared minus 4. Oh, that's too easy. And 53. So 52 and 53, let's do those right quick. How do I factor 52?
Square root.
You could do the square root property. X squared minus 4, what kind of thing is that?
Oh, perfect square.
Yeah, so you can do perfect square. They are both squares, but there is a difference in between, right?
Right.
Difference of squares is the thing that it is.
Yes.
So it looks like x.
Minus 2 and x plus 2.
Yeah, yeah. I already had the plus in my brain. There you go. X plus 2 and x minus 2 are the two things. You could absolutely add that 4 over and then do the square root property, right? This is the same thing, different way. X plus 2 is equal to 0, or x minus 2 is equal to 0. So this looks like x is the minus 2 or x is 2. And so my two coordinates that I'm looking for this thing are minus 2, 0 and 2, 0. Okay. So that's one way we can think about it. This is also an x squared graph. And what would the minus 4 do to it if we're thinking about graph transformations? Going back to that.
Move 4 units down from the origin.
Yep. We have x squared and we subtract 4. We're moving it 4 units down. And so if we're moving it 4 units down, if we go out 2 units, we're also going to go up 4 units, right? So that's another way you can look at this thing. We're going over 2, up 4, over 2, up 4 would give you your intercepts. And probably the last one we'll get through today. how would you do this? The approach, you have 3 terms. So what would you try first? I think we can get it with this one. These all seem factorable, if I'm being honest.
GCF.
There's no GCF here because there's 1, 1, and 6. So between 1 and 6, there wouldn't be anything. Between no x's and an x, there wouldn't be anything. What's the method?
AC method?
AC method. So we do a times c is going to give me a -6 has to add to a -1. 1 and 6 and 2 and 3 are the 2 factors of 6. And if it's a negative, one of them's got to be negative. It's got to add to -1. Which one is that?
2 and 3 with a -3.
Yep, 2. This one, if you want to break apart that middle term, you absolutely can, but you really don't have to. And I'm hoping y'all were like practicing this factoring all along, because if not, I don't know how to tell you, but it's gonna it's gonna catch up to you at some point in this class. We're gonna do factoring quite a bit. What does this factor into? The more you do it, the better at it you get too.
X plus 2 and x minus 3.
Absolutely. X plus 2 and x minus 3. So this is one of those ones, if it's 1, I can just jump to those factors. And even do like a visual check, right? If you're not sure about factoring x squared, I do -3x plus 2x gives me -1x. You can always distribute and sort of check these things in your head. So I either have x plus 2 is 0 or x minus 3 is 0. If this gives me give me a positive 3, so -2, 0, and 3, 0. And so I want to go look at a graph, one last graph. Let's look at x squared minus x minus 6 is what I'm doing. Minus x minus 6. Is that giving me -2, 0 and 3, 0 like I saw before? I think it is. And in your notes, I think I showed you how to do it on a TI, right? I'm pretty sure I did. Do y'all know how to do these on TIs? Do you want to recap?
Could you?
Yeah, it's not hard. I can do a quick recap. Let me pull up that app. Okay. Where is that? All right, so share my TI view. Where is it? Hurry up. Here it is. Share. Okay, now it's coming up. Here's my TI. What I want to do is I want to put it into my y equals. So I hit the y equals. I clear whatever the heck is in there. So I want to do x squared minus x. Is that what I'm doing? X squared minus x minus 6. Is that what the one was? Yeah, that's what the previous one was that we did. This is it. I am done putting it in there. I want to exit out of it. I hit second quit to exit out. So now I have my function in my y1 variable. If I go to the graph, hopefully it's graphed. It's pretty evenly. From -10 to 10, right? I think is the normal thing that it usually does. So if you trace it, this will just like trace along your line, right? You can just trace along the line. You could probably get pretty close with the trace, but that's not what we want to do. You want to hit second trace. That's where all those good options are that calculate. You can find values. You can find zeros of your function, which is what we want to do. You can find mins and maxes, which is like your vertex, right? You can find your vertex with these. If you have 2 lines, you can find out where those 2 lines intersect. That's what that one does. So we want to find the zeros of the function. So it's going to make us pick a left bound. It's going to make us pick a right bound, and then it's going to make us guess somewhere in the middle. Did you get that, or did I go too fast? I know I went pretty quick. So it's second calc is where the option is. And it's like option 2 tells us the 0. And it asks for a left bound first. Ask for a right bound. And it wants us to guess somewhere. So 3, 0 is my 0. Questions? Did y'all get that?
For the most part, mine does not show me like a full graph. I've only got like a small line here.
Go to, oh, you're in the wrong window. So if you go to Zoom standard, Zoom 6, it should zoom it in on the right window, hopefully.
Thank you so much. I've been trying to figure that out.
And you can also go zoom in and out, right? I think the way you do that is with the window. There's your window, right? So if you want to fix your graph, your window tells you what it is. So this is like your min and your max. If we want to go from -5 to 5, and then let's go from like -20 to 20 in our Y scale. This has to be a negative, not a minus sign. Sorry. -20 to 20. We can change the scale even if you want to go by what, 5s instead of 1. So this is the window. Gives you your min and your max, your scale, your min, your max, your scale. So this is going to be really wide, up and down, really narrow, left and right. Same graph. If you want to go back to the -10 to 10, it's Zoom 6 is the Zoom standard. Any other questions? You can always go back to the TI thing.
Sure.
Anything else? I think I'm gonna hit stop
So
on
my
that.
end.